So there are a lot of different ways to do base converters, and I just like this one in particular I'm going to do because it's an application of a floor function. So basically the idea is, okay, I'm just going to remind you how to do base conversions. So if I was going to write 25 as base 3, I'd be like, okay, well, it's something times 3 squared plus something times 3 to the first plus something times 3 to the 0. And the question is, well, what are those somethings? Alrighty. So the first thing I'm going to do is take 25 and divide it by 3 squared, which is 9. And I get 2 and this, so it's a remainder 7. Okay, so that means that 25 is equal to 2 times 3 squared with a remainder of 7. So this 2 goes right here. Okay, so I have, instead of this question mark now, I have a 2. All right, so that 2 goes there. Now I take the 7 and I go to the next one, which is 3 to the first. So I have 7 divided by 3, which is 2, remainder 1. So this is, again, 2 times 3 to the first plus a remainder of 1. So this 2 goes right here. So it's a different 2. It's still the number 2, it's just a different number 2. So this 2 goes here, and then my remainder, if I really wanted to kind of fill out what I was doing, I'm going to take that remainder, which is 1, divided by 3 to the 0, which is also 1, 1, remainder is 0, so I'm done. And then this 1 goes right here. So I have that 25 is equal to, so 25 base 10 is equal to 2, 21 base 3. Fine, okay, but the question is, how would I do this in a more complicated setting? Okay, so how would I do this in a more complicated way, maybe, for example, using floor functions? So I'm going to do this I'm just going to do this by hand and show you another example, I guess. So let's say I wanted to convert 1685 into base 6. Now this is maybe something I can't do off the top of my head. I could go ahead and list, so I can go 6 to the 0 is 1, 6 to the 1 is 6. Come here, girl. 6 squared is 36. 6 to the third is, so basically I'm trying to see how close can I get to this without going over. 6 to the third is 216. 6 to the fourth is 1296. That's getting close. 6 to the fifth is 7776. Okay, so I got over. So that means my first term in base 6 is going to be 6 to the fourth. Okay, so basically what I want is I say, okay, so 6 to the n needs to be less than or equal to 1685. Okay, I can use the property of logarithms to then say that means that n needs to be less than or equal to log base 6 of 1685. Now, because n has to be an integer, is basically, so if I just put in like, remember how I can do log base 6 in the calculator? I can do log of 1685 divided by log of 6. Oh yeah, I remember that now. Where's my log button? Log of 1685 divided by log of 6. Okay, I'm getting 14.14. Now the number I wanted out of that is 4, so I can actually use a floor function. So I can say actually n, instead of saying n is less than that, I can say n is going to be equal to the floor of log base 6 of 1685. And that gives me my n thing to start. And that gives me my power that I'm going to start with. So I'm going to do this on paper here, and then I'm going to show you how this looks whenever you do this in a, what do you call it, in Matlab, for example. So this is going to give me a value of 4. All right, so I've got the 1685 divided by 6 to the, I forgot what it's called, 6 to the fourth. 6 to the fourth. Now let's make the very grand assumption that I'm too lazy to do math right now. So 1685 divided by 6 to the fourth is giving me 1.3.000, anyway, it's giving me 1 point something. So run remainder something. And the question is, well, what's that stupid remainder? Okay. So essentially what I need to do is, so if you think about what you're doing mathematically, to get here, I would go 1 times 6 to the 4th is 1296. And then you subtract, and I'm just doing this by hand just to show you this relationship. 8, 3. So I get remainder 389. Okay, but how do I take this 1.300 stuff and make that, how do I convert that to the 389? How do I get there? So the way to think about it is to say that 1685 is equal to 1 plus, or 1 times 6 to the 4th plus the remainder of 389, right? You're like, yes, I know, you said that like 6 times. Okay, so actually what I'm doing is, in my calculator, I had asked, well, what is 1685 divided by 6 to the 4th? So this over here is what I have in my calculator. Okay, and this is giving me the 1.300 thingy. Okay, well, because I'm amazing at math, I know that I can separate this out to 1 times 6 to the 4th over 6 to the 4th plus 389 times 6 to the 4th is equal to this 1.300 thing. Okay, well, this here is just 1. Okay, you're going to see where I'm going with this? So if I subtract 1 from both sides, I get 389 over 6 to the 4th is equal to 0.300 something or other. So the way to get the 389 is to take that decimal place and multiply it by 6 to the 4th. Okay, so basically I'm going to show you what that looks like on my calculator. You're taking away the integer part, which essentially means that you're subtracting off the floor of this number. So 1.3000 minus its, minus its floor gives me the base, or gives me the decimal place, and then I multiply it by the original divisor, and that gives me the 389. Okay, so that seems like we're going way out of our way to figure this out. We could have just done it by hand, but remember, our goal is to eventually, how can I explain to a computer how to do this? All right, so let's, with all that behind us, now that we kind of know what to do, let's do this a little bit faster. So I've got 1296 divided by 1685, and I know that that's 1 remainder 389. And in fact, I won't even write 1296. I'll write 6 to the 4th, because I don't even really care what 6 to the 4th is. All right, and then I'm going to take the 389. So the first term is a 1. Then I go 389 divided by 6 cubed. I'm going to put this in my calculator. So 389 divided by 6 cubed. Oops, that's not a division sign. Divided by 6 cubed gets me 1.80093. So it's 1 remainder. I'm going to subtract the floor and then multiply by 6 cubed. So the remainder was 173. So again, my next number is 1. I have the 173. Now I'm going to do 173 divided by 6 squared. So 173 divided by 6 squared is 4.8 something or other. I'm going to subtract the floor to get 0.0555. So this is 4 remainder, and then times 6 squared is 29. And then I go, okay, so what's 29? You see where, smell where I'm stepping? Divided by 6 to the 1st. And even though I can do that by hand, I refuse to. 6 to the 1st is 4.833 again. So it's 4 remainder. Subtract off the base, multiply it by the original divisor, and I get 5. And so then I have 5 technically divided by 6 to the 0, which is just 1. And so 5 divided by 1 is 5, with a remainder of 0. And so I'm done there, finally. All right, so that means that 1685, oops. So that means that 1685 base 10 is equal to 11445 base 6. Got it? Okay, so let's see what that looks like if we're going to plug it into something like Matlab. So I'm going to come in here and create a function. So that's going to be something like the converted number is going to be base converter n base b. All right, we're going to assume everything coming into it is base 10. Going to go ahead and save it, and it should save straight up as base converter.m. Okay, so so the number, the number is n, the base is b. Number n in base 10. Okay, so remembering what we did, the current value that we have for n, or how shall I say, like the number that we're wanting to divide by. So the divide by number, I'll just call it the divide by number. So it's either what we start with, or the remainder, or the remainder, or the remainder, but it starts out as what we start with. So I'm going to call it divide by number. It's going to start off as n. That's the first one that we do. All right. Then we've got to figure out what's the exponent do we start with, and the exponent we start with is going to be that log base of the number, and then floor it. So my exponent, or starting exponent, I guess, I'm using really long variable names here, is going to be the floor of the log of n divided by the log base b, or the log base b of n. So I've got that. I'm just going to go ahead and see if I can make these work with the numbers that I already know. So base converter, it's not really going to work very well, but if I put in the 1685 and the base 6, it should come back with a 4 as a starting exponent. That's good. So we got, okay, and that works. I'm happy. Cancel CLC, clear CLC, clear. And let's see. So I'm going to start my converted number. I'm going to save my converted number as a string, just because I want to. There's a couple of other ways to do it, but I'm just going to start it as a string. I can get away with that. It's fine. Because it doesn't really have any meaning. Like if I say, because whatever the answer was supposed to be, the answer was 1145. If I type 11445 in Matlab, it's going to assume I mean base 10. So by putting it in a string, that makes sure that Matlab is like, if someone else was going to use this, they wouldn't accidentally plug it in somewhere and be using it as a real number unless they specifically converted it to a number and knew what they were doing. All right, so basically for k, I'm going to start with a starting, I can't spell, exponent. And I'm going to go down by 1 all the way to 0, right? Because that's what I did. I started with 4, 3, 2, 1, 0. So I got to go all the way down to 0 just to kind of make it pretty. If I kind of take a look, actually, I'm going to scooch this over and come over here and see what I was doing. Okay, so every time I did this, I got some kind of a division answer, right? So I did my divide by number, and I divided it by the base to the exponent, right? So the base to the exponent, so I took 1685 divided by 6 to the 4th. So divide by number divided by 6 to the 4th. And again, at any point in these videos, if you're like, I want to learn more, the way you learn more is you pause the video and you see if you can get anywhere with it, you know. So if you haven't done this in a while, pause the video, see if you can figure this out. Okay, so for the division answer, what I did with that, it became like 1.300015. Remember, that's what that was. It was that 1.30015 thing. And so what I want to do is I want to get the the digit that I want. And okay, and I understand that there are functions that do this. That's not the point. The point of learning computer science and math isn't to be like, hey, check it out, these functions already exist. The point is to say like, hey, how do I write these functions on my own? Maybe one day I can come up with a really clever way to do it. Okay, but the digit that I'm going to care about is going to be the floor of the division answer, right? So it'll be like the 1. Let's see. So normally what I'm going to do is what makes sense is I say, okay, so my new divide by number, or the remainder, I guess, would be equal to whatever the division answer was minus my digit. So I'm going to subtract off the floor. And then remember, I multiply by b to the k. Okay, actually, this isn't going to work all the time, but I'm just pretending that I don't know that, just so you know. All right, so I have this, and that should be my new divide by number. And then what I'm going to do is I'm going to add whatever my new digit is to the converted number. So I'm going to say converted number. I'm going to sprint f, so just I'm just printfing it. If you don't know what this means, that's okay, but I'm going to put a string in front of, I'm basically going to smush everything else down, converted number, my digit. Oops, come here. Oh, I forgot my quotes. Converted number, my digit. Why are you mad at me? Did I spell something wrong? Oh, no, just mad at me for no reason. Maybe? Hold on. Oh, I have an extra comment in there. My digit, Pashuk. All right. I'm going to unsuppress this and run it again for the first time and see if I get the right answer. Base converter. Awesome. So you see I get the number 1, 11, 114, 1144. Oh, no. Okay, so remember I told you that something was going to go wrong. Okay, so I should have 11445, which is why you always work problems out by hand before you try putting them into a calculator or into a function, because weird things are going to happen. It's almost like I picked these examples on purpose to show you weird things happening. So I'm going to unsuppress these things, and I'm going to display k here so I know kind of where I am in the for loop. So now I'm going to run this again. Actually, I'm going to CLC clear, and then I'm going to run it again. Okay, so what's happened, and how is this different from what it's supposed to be? All right, so the first time I do this, actually, hold on, this is going to be weird. I'm going to put a blank line here just to make it a little bit easier, like this. Okay, now I'm going to CLC clear and run it again. All right, okay. So what I'm getting is a 4. And no, not what I'm getting is a 4. I'm starting off with a 4. The division answer is 1. So this is k equals 4. That's what that is. K equals 4. So I have the 1.3002, which makes sense. I have the 1. It becomes a 389, and there's a 1. Perfect. All right, now I'm dividing by 6 cubed. I get 1.800. That gives me a 1 and a remainder of 173. Perfect. That's exactly what I want again. All right, then I divide by 6 squared, and I get 4.80 something or other. Times 4, now my divide by number is 29. Now something is happening that I'm not paying attention to, but if I was really on top of it, I'd notice it. All right, and then I've got the 1 that becomes 4.833 divided by that, and it becomes 5, and this is a converted number. And then I divide by 5. It says my division answer is 5, but remember when I subtract off the floor of this, it comes out to be 4. That's super weird. All right, let's do format long and see what's going on. I'm going to run this again. As always, with a lot of these that are all kind of in this series of videos and labs and stuff, is that it's all coming down to teeny tiny errors way out in the middle of nowhere. So look at this, what's been happening. So even though it told me earlier that the divide by number was going to be 389, it's actually 388.9999999 all the way out. And that's because there's an error. I could have seen this before because there's a difference between 389 and 389 or 388.9999999. Okay, it's not, I did too many 9s there. I guess there is a point where it doesn't matter. Now you're just being obnoxious, aren't you? How shall I say this? Let me do exactly what it's doing then. 389, no, 388.9, there we go. Is that gonna do it for me? There we go. And if I format just back to the regular, if I do that, it's gonna show it, there we go, as 389. I did so many that I made it perfect. If I'm only showing a certain number of digits, see how whenever I did the exact same thing in regular format, it showed the 4 decimal places at all 0, and then here it showed it like this. Whereas if I just type in 389 normally, come here girl, it just shows up as 389. So actually the first time I ran this, when I started seeing these .000s, that should have been an indicator to me of, hey, guess what? Matlab actually isn't giving you that energy you thought you were getting. Something else going on something else is going on, and that's the fact that we're not getting that perfect integer because there's probably some kind of teeny tiny error that eventually is going to come up and bite you, and that's exactly what it did. And again, just to kind of show you what that looked like, if I do my base converter, the number did not actually come back as 389, it came back as 389 something, okay? And I just wasn't paying attention, so I didn't look at it. And so we need to fix that in our code. So we might specifically fix it by saying, okay, floor it or ceiling it, but it could be a little bit low, it could be a little bit high. So what I really want to do is I want to take that thing and I want to round it off. So I'm just going to take my new divide by number and I'm going to round it to the nearest integer. And actually that should solve my problem, but let's make sure. So, put up. Oh, seriously? Oh, because now you're just going to yell at me. I put a space there. I wasn't supposed to. Let's try this again. Why are you yelling at me now? Stupid computer is always yelling at me. Oh, because I forgot the stupid parenthesis. I was going to get there eventually. We'll try this one more time. There we go. And look, I've already got the right answer, which is a good thing. It makes me happy. But now that I look, see, instead of saying 389.000, it's saying 389. This is a really, really, really important concept, and why we study these algorithms to begin with is because whenever we do stuff by hand, stuff that seems really, really obvious, it gets messed up whenever we're messing with, you know, equations that do stuff that are stupid because computers are dumb. And, you know, this is what we meant, but the computer just wasn't capable of doing that. And I didn't have the same problems on my 89. Whenever I was doing these on my 89, I just didn't end up having the same problems because they're every programming language works in a slightly different way and has different limitations. And actually, I've been able to solve a lot more problems on my 89 than on my Matlab because my Matlab is a little snuggly version and not like the big angry version of Matlab. And so, but that said, I was working on something at one point at computers that were, you know, probably worth more than my apartment complex times 7, and they still eventually I was ending up running into problems like this just because even in the most beautiful computers ever, there's still going to be these kinds of basic problems, and so we kind of practice learning how to handle them. Anyway, so I've cleaned it out, and if you want to make it pretty, I just what's that called? Suppress all of those lines. So if I just run the base converter, oh, I forgot my displays. I'll take those out too. Just to make this pretty. Oops, like that. CLC and then base converter. And now we can just pull that number straight out. And yay, this is wonderful.